COSC402. So in this lecture, not take a long time, but just take some time to wrap up what has been introduced in this paper. Then I will talk about the exam, the final exam. So the objective for the 402 paper is to introduce the advanced network topics. So actually it contains two parts. So the first part, we want to train you the ability of developing network programs, which means more robust, more reliable network programs using the socket API programming. So in particular, we introduced the socket API functions. So at the very beginning, I introduced about the TCP and UDP. So COSC402 just give a very brief introduction. So in the first lecture, I give some insights about this TCP and UDP. So, so you need to understand the concept of multiplexing and demultiplexing. This happens almost every layers with the TCP and IP layer. This is one of these. Then for the TCP and IP, for the TCP and UDP, I first introducing the so the diagram of the state diagram. So this one you should understand. I mean, when we're trying to initialize the three-way handshaking project to set up connections, follow this diagram. When trying to initialize the termination of TCP connections, follow that part. So you should understand how the state transition at different stage. So in particularly, for the closing, there's a special state called time away. So why we need to have this time away stage? So actually there are two purposes here. So one is to ensure that the TCP full duplex connection can be terminated reliably, and the second to avoid to just discard the duplicates because duplicates, if they stay in the existing network, it can cause some problem. And to do this, we need to set this for the connection to stay in this state for at least of 2 times maximum segment lifetime. So why we need to have set these kind of settings. So we also introduce about the port numbers, the concept for concurrent servers. What are the basic idea for concurrent servers? Actually, in the following lectures, I introduced 2 approaches to implement a concurrent server. So one is the fork function. That means once a client requests a new connection, we fork a new child process to deal with this particular connection. So the other is based on the multiplexing, I/O multiplexing, based on select. So it does not create more process. Actually, we check the using the select to check if the reading or writing is ready for a particular socket. So we have these two ways of implementations. Okay. Then for the elementary sockets, so the first thing you need to understand the basic steps of developing. Yeah. So the basic steps in developing a client-server program. So at the client side, so the socket API functions we use, and the server side, the socket API function we use. So you should answer because almost every network-based program, they follow the same flowchart. So this is the first thing. Then, before I introduce this flowchart for developing this network program, so I introduce a very special argument. It's called a value result argument. So what is a value result argument? Why we need it? So that's because for the value result argument is works in 2 ways. So when we call this API function, it will pass the parameter, the values to the kernel, which retains or write the value back to the argument. So in 2 directions. we need this because especially for read and write functions. So we claim, okay, we have a buffer size, but when we complete reading or reading, the number of data retained is not exact size buffer. So it's different. That's why we keep track of the retained value, but at the same time we tell the kernel how much space we have. Okay, so this for value result argument and also for the bind order. We have the little ending and big ending, so that's really important. So because different protocols, they might use different bind orders. Okay. Then for the API functions, socket is very simple, just create socket. And then for bind, you need to understand what does the bind function, what kind of, how does the bind function works? I mean, usually we use bind to bind a local particular address. A particular address is a combination of the IP address and port number, and we assign this particular address to a socket. So you can say at the server side we can use bind to bind a particular IP address and the server port number. So in that case, the server program can listen on a particular port number. So using bind, there are several options. So at the server side, so we can bind a port number only by a port number. So if we bind a port number to a server program, it means this port number will be used as a listening socket. So the socket to listen the incoming requests, like a web server, we bind port number 88. So all the HTTP requests will be forwarded to this port number. So this is to only bind a port number. So at the server side, we can also bind IP address. So not only port number, we can also bind IP address. So it might happen that the server may have multiple network interface card. It might be assigned multiple IP address. So if we bind a particular IP address, and bind plus the port number. So at the client side, so if we generate the packet will TCP segment. This segment will contain the port number, right? And we encapsulate with the IP packet. IP packet has the IP address. So if the server side we bind the IP address port number, this kind of packet arrives. So the server only accepts when the IP matches and the port number matches. If we do not bind IP, that means it is a wildcard address. It can receive from any client with a destination, because in the IP address we specify the destination address. So if we bind IP, only the destination address in the packets matches with the IP address we bind, then it will be accepted by the server program. If we do not bind IP, so we just ignore, we just match the port number. This is at the server side. So at the client side, we can also use bind, but in most cases we do not use it. Right? So bind can be used at the client side. If we at the client side we bind with the IP address. So the client side we call bind an IP address. And for this particular application, every packet generated, the source address will use the IP address we bind, just to force that the packet must be sent using this particular IP address. If we do not call bind, if the client has a multiple IP address, we'll just use the one that the packet was sent from each network interface card. So it's determined at the same time. But if we bind, it has to use the IP address as a source address. So this is for the case we can restrict like the source address at the client side, we can restrict at this destination address at the server side. So this is for the case where the bind function can be used not only at the server side but also at the client side. Then for listen, you need to understand how listen was implemented. Actually, this is the function where the process this request of the handshaking protocol. So it maintains the two queues. One is the incomplete connection queue, the other is complete connection queues. So then for connect, simple, accept. So fork is used to create new process. For close, so for close function, it's used to trigger the three-way or the half-close procedure to terminate connections. So in this paper, we introduce two ways to terminate the connection. One is to use close. So for close function, it uses a reference count descriptor. So especially for the case for the concurrent server using fork, every time a new child process is created, the listening socket is increased by 1. Because the fork-based server, it has a parent process. Every time is one client request and set up connection will fork a new child process. And they inherit the listening socket as the socket descriptor. So every time a new process joins, is added, it increases the reference count. So the connection termination will not be triggered until the reference count is declared to 0. That means we call close function. It might happen that connection will not be terminated immediately. Then we usually introduce another API function. It's called shutdown. So this can be used to terminate the connection immediately. So we can not only shut down in one direction, we can use shutdown in both directions. That means we can shut down on reading, we can shut down on writing. So at each side. So the shutdown API function doesn't rely on this reference count. So this is the big difference. And the close is also related to the socket options. We have a socket option that relate to this one. So we can set the values and at what time the close will trigger the handshaking protocol to terminate connections. So it's particular for this close API functions. So then we introduce about the termination, what about zombie process, why this can happen, and how to deal with this zombie process. So then the next, I introduce about the multiplexing. I introduce different file models. So first we need to understand why we need I/O multiplexing. So this gives scenarios. We can give file model, the blocking model, the non-blocking model, our multiplexing model using select, a sigma-driven model, and a asynchronous model. You should be able to understand the difference between them. And I think about because these are the file model we used. It doesn't mean that there's a particular model is all the best. It depends on the applications. You need to think about for a given application which model might be the best. So these I/O models. Then for select, in particular, I introduced the I/O multiplexing using select. So how to using select to implement a concurrent server without forking child processes. Then I introduced about socket options. So for socket options, in particular, you need to pay attention. So some socket options, they are actually inherited from the listening socket, like the options in terms of the sending buffer, receive buffer, the options in terms of the low watermark for sending buffer, receive buffer. So if we want to make changes on the buffer size, they have to be done before you call the connect API functions. Okay, and then the keep alive. So what is this option used for? So why we need it? So this is used for the case where the connection is set up but for quite a long time, there's no data communication between the client server. So if we have such a scenario, it might happen that because for the both client servers, they are not aware of this. It might happen that there's no data. It might happen that the connection is broken down. So how to diagnose this? So we use this keep alive. So after some time, like for every 2 hours, if there's no data exchange between each direction, they will send this keep alive message to detect, see if there's any problems. So this is the purpose to use the keep alive. Right. So this is the cylinder. This socket API function option is related to the close operators. Right. So it's more like a timer. We can set different values to determine at what time the close will trigger this. It will return immediately. Will trigger this handshaking protocol terminal connections. So that one is really important. So why we need this? So why we need to reuse the address? So that's because either the IP address or port numbers are limited. So think about a server. So a port server, a server side. So if we like for HTTP, we use port number 80. So that means that we need to share this port number for different connections. We have to use to enable the reuse address, and the same for IP address. Okay. The next algorithm, what does this algorithm? What problem does this algorithm address? So this is about the IO model and sort options. Then for name address resolution, we actually introduce major 2 type functions. The first one type is get host by name and get host by address. It's a keyword between IP address and IP name. But this one, in most cases, only work for IPv4. So to achieve capability, we recommend you using the get a DDR infer this function. So this can handle either IPv4 or IPv6. Okay. This is for address resolution. So thing I introduced about the IPv6 in terms of the IPv6 address, different type of addresses. So link local, what is a link local address? And in particular for IPv6, it has a capability for stateless auto configuration. That means that we don't need to have the DHCP protocol to assign IP address in IPv6. So each device can automatically generate its unique unicast address, IPv6 address. How this is done, and then also introduce about 2 special IPv6 address. One is mapped from one is the IPv4 compatible IPv6 address. The other is IPv4 mapped IPv6 address. So what are these addresses used for? Then for the coexistence of IPv6 and IPv4. Introduced 2 approaches, the dual stack approach and the tunnel approach to cope with the coexistence of these 2. You need to understand these 2 approaches and compare the advantages, disadvantages. Okay. Then introduce about broadcast and multicast. So this is more related to the So for the multicast, in particular, I introduced the multicast address. So the multicast address in IPv4 and IPv6, and also the mapping of how to generate the Ethernet multicast address based on the IP multicast address. So there's one problem here. It's not a one-to-one mapping. That means there might be multiple IP multicast address share the same Ethernet address. So how does the system deal with this? It's use a two-state filtering. So first filter based on the MAC address because the main-to-one mapping, this is not perfect. It doesn't guarantee that the packet must be destined for this device. Then we apply the perfect matching based on the IP address to solve this problem. Okay. Yeah, this is for multicast. We can develop the multicast program and use the soft options. So this for multicast. So the next two lectures I introduce about the system networks. So system networks, the first lecture, lecture 6, briefly introduce the features of system networks. You should be able to understand the special properties of system network, the potential applications, the challenges. So in terms of design, the major challenge here is the energy. So how to save energy. I introduce. This is more about the config and time use. So how to save energy is mainly for the medium access control protocol and the routing protocols. So how to take into account both the reliability and energy. So for the also introduce the geographic routing. What is the key idea for geographic routing? So you use the location information for forwarding, not based on IDs. So the geographic routing has a problem. It's the routing hole problem, right? How to deal with the routing holes. Then, especially for MAC protocols, I introduce several important concepts. One is the periodical latency and slave. So this is the idea to save energy. So we put because the radio idle state consumes a significant amount of energy. So we just let the radios to be on and off periodically. So once it's in slave state, it can save a lot of energy. But this actually causes other problem because once it's in slave state, it will not be able to receive and send data. So the challenge here, how to explore the best trade-off between the latency and the energy. So go to slave state, it can save energy, but it can introduce too much latency. Then I introduce different type of MAC protocols, like the SMAC and the TMAC. The TMAC trying to aggregate the traffic to sync together, and especially for the Berkeley MAC. So this is one of the very important MAC protocol because it introduced the low power listening. So the key idea to send the long preambles to wake up the receiver. And XMAC do further improvement by dividing these long preambles into short preambles. Why? Using short preambles could improve performance. So these protocols are all sender-based medium access control protocol. I introduced another protocol is called receiver initiate. So this is different from the previous protocol because the transmission is initiated by the receiver. So once the receiver wake up, it broadcasts a beacon to notify the senders, and the sender can send data. So this is different from the sender initiate. So you should be able to understand the difference between these two types of protocols. Then I introduced about TMA, the key idea using time-divided multiple access. Okay, so this is most for the first half, and the second half, we introduce some advanced network topics, including the data center network. So for the data center networks, you need to understand what is cloud computing. So what is the basic concept for cloud computing. So for this center, understand the key components, including the servers, including the storage, different type of storage, and the design of the topology. So different topology designs. So what are the advantage disadvantage of different architectures, like 3 tiers and 2 tiers architecture. So what are the advantages in terms of fault tolerance, in terms of load balancing, etc. So for the research papers, it's not required for you guys to do the answer papers. So what you need to do, just get general idea, like how does the big kit works. So as long as you can understand this, that's enough. Okay. Then about LiFi and network on chips and the quantum networks. So LiFi should be to understand what exactly is this technology. So using the visible light for communication. This is different from the Wi-Fi. So you should be able to compare the difference between LiFi and Wi-Fi. So and the advantage, disadvantage of LiFi and Wi-Fi. Right. So this is for LiFi, and then for network on chips. So you understand what is that the network on chip means, what it's used for, and the different kind of topology like the RAIN tolerance, the mesh topology. So what are the advantage and disadvantage of using these type of topologies? So for quantum network, you just need to understand the basics. How does the quantum communication work? So that should be enough. Okay. So software-defined networking and this is software-defined networking. So first introduce about IoT. So what is IoT? The potential applications and the different technologies, in particular the RFID technology. So what is RFID? So this is radio frequency identification, and this technology has been widely used for short-range communication. So the major advantage that for the RFID tags, most of the tags are passive, so they do not need to be powered by battery. So that's use a technology is called energy harvesting. So the technology that can harvest some energy from the transmitting signals and then use the harvest energy to send data back. So this technology cannot send over a long distance. It cannot send a large amount of data because the energy harvesting the efficiency is very limited. This also relates to wireless charging. So now many of the electronic devices has using this wireless charging, like the electronic brush, like the Apple phones. So they have wireless charging. So, but nowadays, this is still a very challenging problem because the efficiency of wireless charging is very limited. So if you think about the electronic brush, if you think about the wireless charging for the iPhones, so it's very close to a charger. Because electronic field propagation, if it propages over long distance, then the amount of energy we can harvest is very limited. So there are some recent research done by some research labs, like in Samsung, like in Huawei, and in Qualcomm. They actually have spent a lot of time to invest to increase the efficiency of energy harvesting, but now it's still not good. So one of the major technology being proposed in the past 10 years is called the switch. So the idea is that for the cellular phones, when we receive data, at the same time, we're trying to harvest the energy. To transmit the power, the idea that the communication is not only transmitting data, they are also transmitting power. So when the phone receives this data, at the same time, it can harvest some energy from these signals. They can recharge your battery. So, but this is still limited based by the distance. So This is related to the energy harvesting, and there are other technologies designed for sensor inverters. So, because sensors it only send a small amount of data, there are some technology design, but it requires a relatively large antenna size to harvest the energy. So this is still a very good research topic. So for RFID, you need to understand we have different types of tags. So usually we have the passive tag and the RFID reader. So the reader can read the data from the tags. That means they send the signal and the tag just helps a little bit energy, then send the data back to the reader. So we can also have the active readers, active tags. That means it will have batteries. So this is about RFID, the passive tags and the active tags. Right. So this is one of the technology that enables IoT, and there are other technologies. So yeah, other technology I've introduced before, like the LoRa technologies. Is also one of the major technology for IoT. Then for software-defined networking, big data is about big data. And software-defined networking, you just need to understand the key idea, like the separation of the data plane with the control planes. And you need to understand the limitation of existing networks, how the SDN overcome the drawbacks, and how does the open flow works. So this is for software-defined networks. Then we have a guest lecture on Bitcoin and blockchain. So for this guest lecture, you need to understand exactly how does blockchain works. So blockchain be used for Bitcoin becomes very popular. So how does the blockchain can provide security? And so what are the basic principles for blockchains? So that's pretty much for the topic we introduced in this paper. Then in terms of the examination, let's think about the exam. So the final exam will take 60%, and the internal assessment takes 40%. And most of you did really well in the internal assessment. So the final exam, it covers all the topics we introduced. There are 15 questions in total. We use the same format as we did in the past years, and you can get the exam papers for the past years from the library, and you can do some practice. Okay. So all the exam questions are from the topics we introduced in lectures. So that means it's important for you to understand the materials given in the lecture notes, and then you can practice. So the past year exam is just a subset because each year we make some changes on the topics, and then consequently there will be some changes on the exam questions. So only studying the past year exam does not guarantee you can pass the paper. Okay. So in terms of answering questions, so make sure you understand the question before you answer it. Okay. When you get the exam paper, look at the exam questions and think about the amount of time you spend on each question, how much you need to answer, and you can start from the easiest question first. And before you start answering it, first make sure that you understand exactly what you are asked to answer. So if you misunderstand this, then you write something else, then in the middle you might think, oh, this is not the right answer for this, and to cross out. It's wasting time. So make sure that you understand the questions. Okay. I think that's pretty much for today. Any particular question you want to ask?